Hey everyone, my name is Wahid Lutfi. In the series of Python NumPy modules, I'm going to discuss tutorial number 6 today, which is the NumPy OS module. The OS module is inside NumPy module itself. So since we are discussing the operating system, I'll be showing you a lot of examples on the Windows operating system as well as Linux operating system. And let me just go through the slideshow here first. This is a small 3 slides, but the discussion is a lot more since I'm going to go through 2 operating systems with a number of the idle interpreter for Python, IPython, Interactive Python, and Jupyter Lab. So bear with me. This is going to help you a lot. And just let me just show you what resources are available on the internet for you for learning, what I have made available for you online, so you can get them all in just one video. The NumPy operating system module has a number of method and magic method and constants and everything. We're going to discuss both of them on both operating system. The NumPy itself in the operating system modules, both of them on the operating system of Windows as well as Linux. So some of this information that I wrote here are basically very basic, and that you have to understand that when you do import NumPy as in P, then you run a print directory of numpy.os. You see a list of all the objects and methods and everything that is available for it. But you don't need to just import the OS once you import the NumPy module itself. So that's very important. Otherwise, you are going to just have the NumPy already has the OS module, the sys module, the random module, all of them are there. Why do you need to load the OS module separate? Why would you need to import the sys module separate? There's no need for it, so don't import them again. Everything is just inside the NumPy module. And then this is video number 6, but we are going to have a lot more videos on the NumPy module. And this one is going to just show you what we are going to explain on the Linux operating system as well as Windows operating system. So this is my YouTube channel, which is youtube.com/@MyWebUniversity. This is the handle for my channel at MyWebUniversity. So if you haven't subscribed yet, please subscribe so you get all the details. Let me show you what I have on that channel first. I'm going to go through the web browser. And right here is my channel, MyWebUniversity, free educational videos. You're welcome to subscribe. And the reason you subscribe is because subscription is free and you're going to get all these goodies, whether there's audios, videos with some session discussing Linux operating system or Windows operating system or PowerShell or NumPy session 1 through 5. And today we're discussing section tutorial number 6. And there's a lot other ones that are on this page, as well as discussing like cybersecurity kind of aspect of it, and then ChatGPT. So you're welcome to just like and subscribe on this channel. And then there's more than 800 some videos already available. But what is more important is that a lot of these resources, I have made it available on my website for free for you. So you can start watching these videos on YouTube, as well as subscribe to the channel, as well as go to the books that I have made it available for you. So, and let's say just on the MyWebUniversity.com, if you just go here on MyWebUniversity.com, this is the main page. You click on here for next. Now, for Linux operating system, I have written a book called The Direct Path to Linux Ubuntu. This book does not need any Unix or Linux operating system to be installed. And there's no need for you to install Docker or virtualization or VMware. Everything is on MyWebUniversity cloud computing environment on the Linux, and everything is online for you. All you have to do is spend a little bit time every day to just go through each chapter and start learning. And the chapters are very good by I'm showing you examples by examples, and you can practice them. So for example, if you're practicing on chapter 2, the Unix and Linux operating system, notice that I have a table of contents with all the commands here. 33 of them is listed. So when you click on the calendar to just get a calendar command, notice that here I'm giving you examples and the man pages, everything. So you click on the calendar to just say, what is the calendar? Dynamically, it runs on my Linux cloud computing environment and gives you the current calendar. So the command is very much like whatever you type in. Like if you type in date here, then it will tell you the date today. And if you just change that one to, obviously for each chapters, these examples are there, but I'm just showing you that you can run like uname plus A. So let's say I go here on the command for chapter 2 and look for the uname command, which I showed you there because the parser did not parse it correctly, but I'm going to just show you here. So this is chapter 2, and then the uname might be on chapter 3. If you're interested to find out the uname command, so look for it. This is chapter 4 actually. Let me go one chapter before that. Chapter 3 is intermediate, and then uname might be here. The command uname, let me just see, Control F, and then look for uname. It is not there, so it must have been on chapter 2. Let me just go chapter 2. And so I made the whole thing very easy for you to look for them. This is chapter 3, and let's go to chapter 2. Yeah, uname is right here. So you could have done Control F here on chapter 2, type in uname, and it is highlighted. And you click on it, you just say, okay, I want to learn the uname. Notice that the examples that are here, uname by itself, uname -A, which shows all of them. And you can see the output is right here. That's a Linux server. So this is your command, and this is the output. So you don't need to install a Linux machine. You just run the command and get the output. Like uname -M for machine type, you could just see the x86-64. Uname -O, it is going to give you the like a uname -S for system, and uname -R for revision. Every one of them, you could see that this is the revision. So the commands are very intuitive. At the same time, I made this thing available. So if you're interested to learn the command and say, I need to know more about it, and then you can run like a man page on it. So for example, let's say cat was the command that you say, cat the contents, concatenate the contents of etc network, and -N means send it like a line number. So it shows that it's 2 lines on that one. So if you did that one, it will just give you the output here. But at the same time, if you want like manual pages for the entire Linux manual pages, there's about 6,600 PDF files here. All of them are available for you. You don't need to buy any book. Everything is available for you. And some of the users that they actually used and subscribed to my channel, they thought that this is a treasure that they were looking for. Honestly, it is there for a developer's dream. I wish I had these kind of resources available when I was a student, and all of them were for free, available online. So when you're looking for like uname, Control F here, just type in uname and then look for the uname. There's 4 of them. So this is the uname that I'm looking for manual pages 1, and then just give you the output here. So you understand it, practice it. Online, you can just either use those chapters from the book, chapter 2, 3, 4 for all of them, or read the manual pages and then do it online as well. So there's also chapter 5 of my book. So if I go to chapter 5, why I'm showing you this one, because we're talking about the OS module. Whether you're using Python or command line of Windows or Unix, you need to understand these commands that you're going to run the system. So in addition to the 6,600 manual pages that I showed you, we also have the about the HTML version of it. This is all in PDF. Chapter 7 is all in HTML, so you can get it. And then also you can go on the Unix and Linux shell scripting on chapter 5. So you can actually practice it online. So if you learn the uname command, you could just click here and say, okay, can I practice it now here? And then you say, yeah, you can just type in your command that you know, uname-a, and then click on submit. It will just run the command and it will give you the output right here. This was your command that you type in, this is there. So if you say, is it this the dynamic? You say, yeah, calendar 9070. Let's say that give me the calendar of 9070. So it is just generating it on the system, on the cloud of MyWebUniversity.com Linux web server. And if you just say, how is that dynamic? Look at the time. I type in date here. I get the output for the date based on the timestamp of what it is currently on the Eastern time, 1:27 a.m. in the morning. So if I just run the date again, notice that 27:14, and then I get a different result, meaning that a few seconds later, I run that command there. So if you're just learning Linux and you say, what does ls-l do? You just run it and you get an output. What does pwd do? It is there, they get the output. Give me the current user that are logged on, who is logged on. You could just run who and then get this. And then get the current calendar, just run that. And I'm going to show you this inside Python and the NumPy OS module. That's why I want you to understand that how flexible I made this website for you in order to help you as a student or as a developer to enhance your career for future. Believe it or not, if you go to this page, start learning, you're going to get at least right here 66,000 technical documentation on Mac OS X, Linux, Solaris, operating system, Windows, PowerShell, Windows and PowerShell. So each one of them you click, you get the list of tables and then all the commands you do. For example, you say, what does the 3 command do? You just see the output here. Really nice formatted and everything. Same thing with the PDF files. So if you go say, I learned a lot about Windows, now can you show me the Solaris operating system? Right here, Solaris, which is Unix. There's about 13,000 technical documentation here. So if you're a Solaris person, you're looking for something like zettabyte file system or zpool or some other commands, prtconf, all of them are there on the manual pages. In addition, if you're looking for, this is help on Windows. So everything on Windows is in a PDF file here too. So like, for example, let's say you want to learn in Windows how to do a for statement, click on for here, and you get the for statement and in a nice format, PDF. I wrote this one program, the PDF program that I wrote it using Python and FPDF library generator, which was a module that's inside Python. At the same time, I used the Windows operating system help functions and help commands that are available. And then I generated the PDF file. And this is your generated PDF file here. So if you're looking for Windows operating system commands, this is the page that you want to bookmark. All the 62 commands that are there, it's all in a PDF format. And then similarly, like if you're using the if statement, there's that if statement in Windows operating system. And the syntax sometimes is very intuitive, like it tells you this kind of information. So all you do is learn it and practice it on the Windows operating system. Okay, so at the same time, if you're looking at Node.js, this is also like a table of contents, all PDF files. So if you're looking for something like what does the Git do on the Node.js, and then it tells you that exactly all the help on it. At the same time, if you're looking for something, let's say, for example, the access, for example, and then you can see that what it is, all in PDF format, not a package manager commands. And then again, Node is really good, Node.js. I'm going to have some videos later on for you on that one as well. But this is also for PowerShell. So if you're looking for PowerShell, bookmark this page. The entire PowerShell documentation, I made it in a PDF format. It's more than 1,394 commands altogether. As you can see, it is huge. You can go and then just practice all the PowerShell. So if you're looking for like git dash process, do a control F here and say git dash process. And then just right there, it's going to find the git process. You click on it and then start reading and practicing it there. Again, and the commands that are here are very intuitive to understand it. GPS is the alias for it, and PS for process is the short alias for it as well. So like if you're looking for git dash disk or something, just do a same thing, or git dash disk. So git dash disk, and then there's git dash disk image, git dash disk, and you click on it and read about that git dash disk. This is all PDF format of this. On Windows, or actually on Microsoft, if you go there, there's this documentation available. But sometimes it's very easy to just go in one website server and get all the resources, whether you're looking for Windows or Unix or Node.js or something. So I'm making this website for students to be just kind of like free resources online available, and it is all supported by all these companies. So I give full credit for the companies. For example, for PowerShell, it is in the center here. It's giving to Microsoft, and then Python for making this programming language available, FPDF library, the same thing that this module is available for me to write the whole code. And then for myself on MyWebUniversity, I make it all available on my web server. So all these things, I pay for it, and then you guys are using these resources for free. It is just available for you. All you have to do is go to the my channel, subscribe, and you will get thousands of documentation videos on a daily basis or weekly basis as I update them. So if I have time on vacation or holiday, I make these videos for you, or in the after hours when I make them. So enjoy it and learn it and practice it and help yourself, help your family. So here, this one, we already showed you the PowerShell. We showed you the website itself. So one more thing that I want to show you on Windows operating system. So let's say on Windows operating system or Linux, you learn the command here. You can also open a command prompt if you have a command prompt and practice it there. So what I'm saying is this help, all this one was all on the local machine, but in order for me to make it in a PDF format, I had to write a Python program to generate the whole thing for you. So you can have it all the time available, whether you're logged on in front of a Windows machine or a Linux, it's all on the web for you. You can just use your cell phone and just go to the website and then bookmark it and then start learning. There's going to be a lot of resources. Some other person that was communicating with me wrote a very nice comment that I was very pleased to listen to it. He says, this is something that I was hoping that someday is going to come, and now that it's available, I'm so happy. He's like, right, ooh, or something. Wow, that was so excited that to see somebody think of the same way that he was thinking. Another person thought that this is a treasure, and then he found it, and it's very inspiring for him. And I'm very, very happy that I want to just help people. And then as long as you guys are just going through the channels, whether it's my YouTube channel or somebody else, if it is free, and try to see some kind of benefit from it. See how much it's going to benefit your life. What kind of changes makes in your life. So that way you can do it. Without further ado, let's just get started with today's session, which is NumPy OS module. I have discussed a lot about the operating system. And when I say without further ado, that was kind of too late, but the fact that we were talking about OS module, I introduce you with the resources that are available. And if you don't know about the resources, for me just to discuss the NumPy OS module and not tell you what you can do with the Linux operating system and Unix operating system, it's kind of useless to know what you can use with NumPy module, but without knowing that this is available also on both operating system. Portability is very important too. So this one, we're going to just go first on the Linux side. As you can see here, I'm on a Linux machine. So clearing the screen, if I say uname -a, you can see that it's on a Linux operating system. If I look at that cat etc os-release, it tells me that I'm on a Ubuntu 20.04 long-term support. So that is what this Ubuntu 20.04.5 LTS. LTS means long-term support, which is at least 5 years from the date that it was released that will be supported. So at this time, you are going to see some commands. So let me clear a screen. I clear a screen with the Linux is clear command, not CLS. CLS is on Windows operating system. So in here, since I'm on a Linux operating system, I'm going to do which Python first. Which Python 3 is telling me that I have Python 3 already. So Python 3-v is going to tell me the version, and I could also say -- version would give me the same thing. And then Python itself, if I type in this command, it will just drop me to the Python interpreter. As you can see, it's 3.8, and right here it shows that it's 3.8. So when I look at the commands that are available for me, help is available, copyright and credit, all those ones, license information. At this time, I'm going to show you NumPy stuff. So with NumPy, if it is not loaded by default, this is the object that are available for us. All the double underscore, we call it dunder method or magic method. All of these are there. But when I want to import a NumPy as NP, at this time, I just imported it. And when I do a dir of NumPy, dir, now it shows NumPy is loaded. And then if I want to just know the NumPy, there's a double underscore magic method. It says the version that I have 1.3.2. And at the same time, I have a method called the dir of numpy.os. Notice that there's so many of them. So many methods and a constant and everything that are available here. As you can see, the list is on and on. So there's a big list here. We're not going to show you everything on this OS module, but I'm going to show you a lot. And when I show you a lot of the things that I'm going to show you, I'm going to try to show you like a template so you can duplicate the same learning process and do it yourself on Windows platform, Mac OS X, and Linux, all of them. Mac OS X is based on BSD Darwin version. So whether you learn it on Linux or Unix, Unix is Solaris and Mac, and then FreeBSD and HPUX, all of those ones. And Linux is like Red Hat distribution or Ubuntu distribution or let's say SUSE, OpenSUSE, or some other distribution. But all you're doing it here, the distribution is Ubuntu on Linux. So we did the NumPy. Let me just look at the NumPy to clear this screen. So I'm going to say np.os.system, and then inside this command, that whatever command I do, that command will run. So right now I'm saying that the np module, that alias that I'm creating as an alias, import NumPy as np, now has another module called OS. And that module has a method called system. And the argument to the system function call is clear command. So it clears my screen, and it does. So at the same time, now instead of that one, I could type in that uname -a inside here. Notice that it tells me the same thing. So if I go uname -kernel name, it will say the same thing that was doing it from command line. So any command here I type in, whether I type in pwd, calendar, date, whatever command I do, the operating system np numpy.os module, it runs that one. So all the system calls that I'm doing on numpy.os.system are being executed at the command level. So if the command is valid, like here, let's say I run a df-h, that's a valid command. If I run a calendar 1970, that January 1st of 1970, so that is the month of January, you can see. If I wanted calendar 2, calendar 2, that would be February, so you could get the February. But notice the calendar 1, that's the Thursday, that epoch calendar of Unix AT&T Bell Laboratory version was introduced by Ken Thompson and Dennis Ritchie at the time of 1970, back in 1969, 1970 at the AT&T Bell Laboratory. So the epoch calendar started on January 1st of 1970, the Unix calendar. So here, notice that you're getting, for every command that you run, you get a 0, meaning the command runs successful. Because we're doing this system, in addition to get the output, it's going to show the one. So there's another method called, like if I say dir of OS, numpy.os.popen, process open or pipe open. So this one basically is going to show me all the double underscore method that is available for this one. If I just want to not get this successful status, notice that when I'm running a command here on this command that I'm doing, when I say clear the command, this command successfully finished, and then it gave me a 0. If I say run the who -r, the run level, then it's going to say it ran this command and it finished. If I say which chkfs, it's going to tell me that that command did not find. But let me say file system checker. And then it says, okay, I found the file system checker on the user bin, and this. Notice the command that was not there, chkfs, it's not there. So this is returning that one. That's like saying something like, say, echo. Let's just write something here, testing, just like that, testing, and then put that one. Since that is testing shebang, or testing bang is not a command, it is just going to say testing not found, and it gives you a non-zero number as return value. But if I say echo and then put that one with a double quote, because that operating system command is valid, it says testing and then a return value of 0. So if I don't want to see that return value, this is what you do. You say, you create a stream. So you say a stream is equal np.os.process open, and then you put your command. So the command is, this one is, say, let's say we do the calendar command, the current calendar for today. So for this month. And then we say output is equal stream.read. We read it and then say print output. So now notice that it gives me the output here, and it is just doing the exact thing. So what if I want to run more than one command here? Maybe I could create a list of commands. So in Python, a data structure called list, you can do something like this. Say, let's clear the screen first. Clear the screen, and then now this time I'm gonna just say commands, which is the list of commands. Inside the list, the data structure, I'm gonna create the command, for example, let's say calendar command, the who command, who minus r for run level, the uptime, and then let's run one more command, say host name, or another host name. Let's just say uname dash o for the operating system version OS name. So we are going to run this, and then now notice type on commands. This one is a list. So if I say commands itself, it's going to give me those lists. In order for me to just run each of these commands, I could do something like this. For CMD and commands, just say print numpy.os.system, and then run the command here, CMD, and then just close this one and then run it. Notice that for each command, it ran the calendar command first, which was this, the who minus r, the run level here, and then the same time the uptime, the load average and all that thing, and then the uname dash o, which is saying that it's GNU version of Linux, the operating system. So I don't want to see this one. Let's see the same command if we do within the pipe open process. So we're going to do another clearer screen here this time. And again, commands already has that one. So I'm going to say for command n commands. And then here, since it's a list, I could do all of them like this, saying that from start cal to all the way to uname dash a could do this one, or I could just do omit it and write it short. So here, this time I'm going to say stream is equal, and then say numpy.os.popen, process open. So at this time, we're going to open the process for command, and then we're going to say output is equal output, and then for the command, we're going to say stream.read, and then let's say print out the output. And when I press enter, it's going to run this command first, and then it's not going to give you a status of 0. It's going to be successful, and then the same thing with who minus r and so on. Let's see if it does that. And notice it does this. It ran the first command, the second command, and then the load average. So it is very nice because what you could do is use this clear command here, and then the list of the command that you do, you just could add into the command, whether you're doing it commands.append, and insert another command in there, or you could just come in and if you're writing a code, you could read it from a file, or you could do all of them. That's how I'm doing those commands on my website to show you all of these commands, running these commands. So it's very, what I'm building, I'm showing you here. So it's very good for you to learn these things. So let's say add another command, say, what other command we could do is say, let's say the date command is not there. Yeah, we could run that simple command so you don't have to get too confused with the rest of them. So this time, if I say for command and commands, and then just do the same stream, and then output, and then print it. Now you see that at the end it run the date also. So you can just use the list.append to add it, or just modify your list to add more commands, and it is done. So now I'm going to show you one more things with NumPy iterator. So this time, let's go with the clear command here again. This one. And so now commands is there. Type of commands. This one is also a list. But I want to just create a NumPy array from this list and see what it does. So I'm going to say array 1, which is my array. And then I'm going to say numpy.array, and then method. And then here I'm going to just say commands. Let's say, so I'm going to just say commands, which is going to be numpy.array, and then it's going to add this list inside this parentheses and that parentheses for the array object, the array method. So now I have array 1, and notice that the entire list is up to here, and the data type is U8, which means it's a list of strings there for each one of them. So, but this is array 1. So if I don't want to see the array, I could say array1.data type. You can see that it is showing U8. And if array1.size, it will tell you that there are 5 commands, 1, 2, 3, 4, 5. And then the number of elements in there. Item size, each one of them, how big it is 32 bytes. And then that's the storage size. Like the data type we did, let's say the shape is 1 dimension, but 5 elements. And then if I want more details on it, I could say info numpy.info, and then inside this one, I could say array 1. And notice that info numpy is going to say it's a class this. So if I say array 1 dot type of array 1, type of array 1, you could see that it is just numpy n-dimensional. I mean, the multi-dimension array. So here it is giving me all the details with the info method also. But again, array 1 is just that. So let's clear the screen. We could just say numpy.os.system, and then clear the screen here. And then since array 1 is that, if I say type of array 1 is just going to show numpy, but I'm going to just create a iterable object from it. So in order to do that one, I'm going to just say array 1 underscore iter, and I'm going to say array 1 dot flat. So now I'm flattening it. Even if it was 2-dimensional, I would flatten it, but I just did this one, even though it's 1 dimension. I'm sorry, array 1, I must type here. So array 1 now. Now type of array 1 underscore iter, you can see that one is basically as a flat iterable. meaning that whatever was an array 1 here, I could now iterate on it. So I could say for item in array 1 underscore iter, and then do something with it. So I could say run the command. For the command, I'm going to say print npy.os.numpy.os.system. Let's just run the system, and then we say item, and it run all of them. But if you want it just for the popen process, and instead of that one, what we wrote on the system, we could have done the popen. But be careful when we are doing iter versus a list. So now if I say for item in array 1 underscore iter, print item, I have already went through this iterable, so it is not having anything in it. And in order for me to just have this one, I have to do the same thing again. Say array 1 underscore iter is equal array 1 dot flat. So because array 1 is already defined, now I can go through the iter. This time, if I just do this one for item and iter, this time I'm gonna use the stream. So I say the stream is equal numpy.os.popen, and then here I got to say item, and right here I'm going to say output is equal stream dot read. So we read the stream and then print the output. And notice that now the iterable is this time work because we just initialize it. Now the iter is, underscore 1, the next element is empty because we went through all the lists. So don't reuse the same one without initializing it every time. That's the difference between the iterable versus list. The list will always be there. So no matter how many times you want to call it, it will always be there. Each element you can index it at the time that you want, depending on which indices you are going to point to it. Okay, so there's more commands here. So let me just do one more and say np.os.system and then run the clear screen command. And then at this time I could say np.os.get current working directory. It will show me that one. np.os.get login. So I could get the login. There's a lot of these methods. So in order for me to know just about the get methods, I could say for item and dir of in numpy.os, and then just say if get n item, then show me all those ones. Then you could say print item. This will just give you all of them. And now notice how many of them are there. But this is inside the idle interpreter. So in order for you to get a list of all the commands, you could either do the, let me just do a clear screen again. You could either do dir of np.os and just look at the method that are available for you, like set a user ID, set group ID, all of those ones are there. Write, walk, and then terminal size, all of that information is there. You can use them and understand them. And some of these constant, you can get the value of it for it as well. So like os.path is there, sys.path, and other modules that they have there inside NumPy, you can get all of them. But if you're not like a person that want to do inside interpreter these commands. You want to use a IDE, integrated development, Python, like maybe PyCharm or maybe Jupyter Lab or IPython. Let me show you the IPython version. So right here, you did this one. Let me exit out of this and then clear my screen from the OS level. I'm going to say IPython. So first of all, I was showing you that pip version. You can also do a pip list and then grep -i NumPy. And so you can get the NumPy version, like we were seeing that NumPy was 1.23. Inside the Python itself, I said import NumPy as np, and then we could say np dot dash dash version. Earlier I showed you. So you can get that one or say np dot os dot system, and then just run this command from here, because that's the command inside OS, and you just get the same information there, and it will just tell you the Python version that is there. And again, similarly that. So whether you type in exit or quit, as long as you write it as a function, it will do it for you. So here I'm going to clear a screen. I'm going to just say which IPython, the interactive Python. What's the advantage of interactive Python? That some of the method that I show you inside the idle integrated development learning environment, I'm going to show you on IPython here that is much more kind of like helpful in order to just say there are certain histories, there are certain aliases, there are magic method, the list method, and there's a lot of commands on the operating system that you can run. For example, you could do something like this and pwd, and it will run that one, and you say uname -a. You could get the operating system command. You could also get the like pwd, but if the command is having arguments, sometimes it's good to run it with two bang. But also here you have aliases, so a list of all the aliases that are available here with the NumPy. But in addition, and the NumPy IPython, you could also say a list magic, list of all the magic that are available. There's a number of things. When I discuss the IPython interactively on another video, watch for that one. I'll discuss all of these ones in more details. So right now I'm going to do a clear screen because it was part of an alias. The clear command is available. I don't have to put a bang in front of it. So if I just want to do ls, that does ls what the colors like here, you can see that one. And if I just type in history, all the commands that so far I did will show that one. But let's get with the NumPy first. Clear the screen and say import NumPy as np. Notice the color is very helpful, and also the other advantage that IPython has. So if you say, what are the commands that I can do with np.os, for example? Yeah, you can get the same thing like inside the Python, but let's clear the screen. This time we're going to say np.os and then put a question mark here. Say that give me help on it. See, every object that you work on, it will just give you based on that one. .system and then question mark on the system. And then get current working directory, it will tell you about that one. So the command that you type in here, like for example, pwd, question mark, it tells you the pwd. So this question mark is almost like help on the NumPy that is there, but and also you could do it based on the object. Okay, so another advantage that IPython has that I really like is when I do this and p.os. So right here I could tab it, and all of a sudden I could see all the commands that are available for me for this one. So if I look at the get and then I say I don't know the rest of them, everything that is stored with get is going to give you by pressing tab, you will get a list of the commands that are there available. So this is very useful also in that sense. And then you can just say, well, how about the get process ID? And it gives you the current process ID of that one. So if I say np.os.os. System, and then I run the ps minus efa grep minus I Python, and then grep minus v grep, this is going to just run the process command on the EFA, means show me every file and all of them. Grep minus I means show me only the IPython and ignore the case sensitivity. Grep minus v grep means don't show me the result of my grep command. So this should give you the process, and notice that here, this process is exactly for the IPython. That's why when we say that process ID is there. So whether I type in here, pwd here, or I just run this command here and type in pwd here, it will be the same output. And then if I don't want to see the 0 again, inside Python, I could have done the same thing. Say stream is equal, open a stream first, and I say numpy.os.popen, process open, p open or pipe open. Pipe and process is the same, basically. It's kind of a virtual proc file system, pseudo file system, we call it. So p open, and then inside here, you're gonna just run the command, let's say pwd, and then say output is equal stream dot read, and then say print output. Now we have the pwd result /home/wlutfi. It will just show you that output. But because we did a stream, and this successful result, that's obviously doesn't have to show. Now, let me show you what is this successful result on the operating system side is. So when you exit out of this one, clear your screen, and if that command that you just run, $? means successful. So here the thing $? again is successful. So if I just do something like this, that command not found, now $? meaning that it's non-zero. If I just say echo, this is a test, and then now $? successful. That's what that $0 means on return value of the program, whether the main run successfully or not run from a C program. Usually the return value is there. So this was all about the Linux side. Let's jump into the Windows side. Windows side, we can do the same thing. Say Python 3 -- version, or Python and --V, it will tell you. So the syntax is very similar. Python 3, I'm inside Python. Import NumPy as NP. Perfect. It's going to load it. Dir, I see the NumPy here. And this time I'm going to say, just do a quick thing to say print np.os.system. And this time, because it's a Windows directory, I could do a clear screen by doing this, CLS rather than clear command. And then just close that bracket, and it's going to do that. So let's just say, and instead of clear screen, I'm going to say which operating system I'm using. The host name is going to show that. And if I say, show me the ipconfig command on Windows, and then just the output of it there. So let's clear the screen again. Clear the screen with the CLS because we're inside Windows. So I'm going to say np.os.name it is going to show in T. On the Linux side, if I go to Python 3 here, import NumPy as np, and I say np.os.name, you can see that it's POSIX. And then here np.os.uname also tells me that it is a function, and then it tells me that it's the entire thing as if we were doing uname-a. It will tell you that it's the output is right here, similar to running the system with uname-a. But the print statement is a little bit similar, like this one. All the way here is coming as system name, and then this variable name that are saying the node name. So inside here, if I want to get only the node name, I could say uname-n here. That would just give me MyWebUniversity.com. Similarly, if I want to go the Linux, the system name, I could do -s, because here it's a system name. So here is the argument is -s for system, and so on. I mean, you can get the machine type and platforms -p and so on. But all of the details here are just the version numbers and then so on. So we did show you this one on Windows and Linux, and let's get to just run some commands on Linux with a list first. And then obviously we can do with array and everything. And instead of creating a list, we call it commands is equal numpy.array. And then we just call it an array already to start with. And we say, let's run the command directory with /w, the white information. And then we are going to do, let's say, nslookup google.com. And then we say nslookup www.mywebuniversity.com. And then let's also ping google.com. So just like doing these commands on the Windows side, we just run this. And now I have to close the array, because NumPy, when we did this one, we had to actually start the array here. I mean, the bracket with the list inside here. And then this is my list. Now commands has that information. And then print commands has that. But type of commands is, you see, ND dimensional array, NumPy ND array. So at this time, we have those ones. Let's execute those commands. We are going to say for CMD and commands, we're going to just say, let's use the p open stuff there. So stream is equal, I'm going to just say numpy.os.p open. And then what is the command that we're running is cmd. And then say output is equal stream.read. So we read the stream for each command and then print the output. Very simple. So here you run it, and let's see all the commands are getting executed. And let's go through the list of the output that are saved. The first command was dir command right here, dir/w, and this is the output of dir/w. The next command was nslookup on google.com. It did show the IP address of it, and it same thing with MyWebUniversity, and then same thing with ping Google. So a lot of those ones, some people, they say, why you're showing the IP address? Whether you are showing or not, those IP exist. People could always run the command and get it. It is not like something secret. Those are DNS names that are pointing to an IP address, and those IP addresses are always through commands, people can get that information. So here we're doing is, let's just go to some other commands. So I'm going to say np.os.system, I'm going to do a clear screen. And then this time I'm going to say, I'm going to check the F statement. If I say F and np.os.name is equal nt, that tells me that I have a Linux Windows operating system. Then I say np.os.system. Let's clear the screen first. And then after that one, what do I want to do? Let's say run the command called, let's say type something, or maybe run a calculator. Let's just run two commands here. We could put those commands in the list, or maybe read it from a file. You could do it, but for demonstration, to make this video not too long, I'm going to just run two commands here. So I'm going to say np.os.system, and we're not going to use the pipe, so we're going to just say calc for calculator.exec. This one we're going to run, and then we are going to say np.os.system, and then let's create a file. We say echo testing testing ... and then just create a file called test .out. So we just name it .out, a file, and then close the single quote here. And then here we say np.os.system, and then we run the dir command on test.out to see if that file got created. And then if it got created, we say np.os, assuming that it got created. We didn't check any testing to see if it exists or not. We're going to just say run the type command and then test.out. We should see testing ... at the end of it. So we're going to run that one and close it. So let's go through the commands. We say if np.os.name is nt, which is true, then it's going to say clear the screen, then run the calculator, echo testing, and create this file with this greater sign, meaning that overwrite whatever is in this file. And then if it doesn't exist, it creates it. If it exists, overwrites it. Dir test.out, it will do a directory listing, and then it prints it out. So it cleared the screen, and then notice that it opened the calculator. So I'm going to close the calculator, and notice that it created the file test.out with 16 bytes, which is this 16 bytes, and it is there, and it listed there. So all the commands succeeded. You can see 00 successful there. Similarly, if you want to just do the same command, you could open other commands. You basically, what I showed you here, it's all available. Another thing you could do is on the command prompt, we just showed you the option. So let me just do another thing here. I'm going to just go to a directory called C demo, C programs, C Python, CD, and then now here I'm going to just start the NumPy module. So let's see, start.tutorial 6. Do I have one? Tutorial 6, I don't have it. I could just start a fresh one here. So here, when we do this Jupyter Lab, you have to start a Jupyter Lab like that. It will just start Jupyter Lab. And once that one is started, it's going to take a few seconds or a few less than a minute to start it. But it's going to open a port, localhost at port 8888 48s. And then by default, it's going to open that one. Then you're going to have a interface. Jupyter Lab is really, really, really helpful because it has a very nice interface. Then you have the IPython. You have a lot of other kind of resources with it. that you can use and take advantage of it. So if you don't have Jupyter Lab, don't use Jupyter Notebook. Jupyter Notebook is kind of like almost like deprecated. It is not as much available on it, but Jupyter Lab has a lot more to it and a lot of more features, more functionality, and a little bit much better. So I'm going to clear my workspace. Every time you clear your workspace, it's just start a fresh session. And if the kernel gets stuck, you sometimes, depending on the resources of the Windows operating system, you have to do it. So here, notice that when I say a lot of resource, so under the Jupyter Lab, you have a notebook as well as IPython 3, which is the IPython kernel. And then you have the console you can open. You have terminals that you can run commands like we were showing on the Windows operating system commands. And then here terminals, whatever the operating system. So when you click on this one, you get the Windows operating system. If you're on a Linux, the terminal is Linux commands. So every command that you type in here are based on the OS operating system. You see? So if I just do a clear screen here and then say nslookup oracle.com, you can see that I get the data there. So a lot of the details of this one, like fconfig, ipconfig is there, commands that is there for DNS stuff, or cache, and everything is there. I'm not going to run each command, but you get the idea. So inside here, you can also click on another tab and just open another tab. So you can create a text file, you can create a markdown file, you can create a Python program to run, and then you can do a show contextual help. You can do HTML stuff, a lot of stuff you can do. But in this case, we're going to do a IPython 3. So when we get the IPython 3, you can name it here, rename it to something that you want to do. In this case, since it's NumPy module tutorial number 6, I'm going to call it NumPy underscore tut underscore 6. That is the name. So I'm going to click on rename, and it's renamed there. And right here, by default, you get these cells that you can run and practice with all the commands. At the same time, I think this is a little bit too big for this screen. So let's see if I can shorten it. And if I just do a little bit like that, is good enough. We see a little bit more window here. And then when you say import NumPy as NP, notice here I just need to make the size a little bit bigger so you can read it better. That is better, and that's what it was originally. So I will just keep it like that so you can read the thing. Import NumPy as NP. This is a silent mode, and NumPy NP is already loaded. So if I just run this one, and if I say type of NP, it's gonna say the same thing that is NumPy module is there. But if I say type of NumPy, it's not going to show NumPy yet because it's not loaded just because I want to use it. This one is going to not load it, and it's going to give you this error saying that NumPy is not defined. In order to not see that one, you have to import it. And when you do import NumPy as itself, then you run it, and now it says it's a module. So notice that this one is going to say module, and the other one says is a module. Because this one is an alias that's pointing to that. So if I just change this one, say, and instead of type, I say dir of print, dir of NP, and then here I say print dir of NumPy, I'm gonna get the same method and all the things that are available on this one. You see all of this is exactly the same output as the one for the NumPy because they're both pointing to the same thing. So let's just minimize. And then the Jupyter Notebook, when you click on this one, if you click on this, you will minimize this one so you don't see it, the output, which is nice. So here we did those ones. Let's do a print dir of NumPy.os module. So you can see that if I run this one, I'm gonna get all the methods that are available for NumPy.operating system. Okay, so if I look at this one and I say, okay, that's great. Let's just see a couple of the methods here. And notice that this one, the OS dot on the Python, I'm sorry, on the Linux, we had this uname method that I used here. Remember I said np.os.uname. So that same method may not be available for you on Windows. In order to do that one, you have to use a different function. So here we do have print np.os.name because that's going to show nt. On the other one, it is going to show POSIX. So print np.os.name. This one is going to show POSIX. So Mac, Linux, and Unix, all of them. Mac is Unix, BSD version. So they are going to show POSIX, Portable Operating System Information Exchange. And then when you do on the Windows, it shows NT, which stands for New Technology. Microsoft NT version a long time ago when it was built. 3.51 was the first version, and after Windows 95, I believe, or before Windows 95, after Windows 3.1. So here, this one, we're going to talk about the NumPy.os. Okay, so we discussed that one. Let's just run the commands here, print dir of NumPy.os, and see what is available here. When you look at this list, it's a lot. And then if I want to just know if there's a uname or not, and notice the utime is there. The uptime is different than the utime. And you can see the umask and all the other commands are stat that are on Windows. On Linux, they're also here. Get current working directory. So let's just do a couple of the NumPy OS module. I'm gonna just say for item and dir of NumPy.os. I'm gonna say if let's say get or get an item, or let's say what other things we want to see, get current working directories and stuff, or utime, or uname. Let's say just say name, because that would cover name and as well as uname. In item, and then print item. So let's see if there are methods for that, those two, and instead of just getting all the big list. So here is the list. So a lot of the get environment, get current working directory, get login, all of them, get process ID, get the parent process ID, all of them are there. And then the name is there, rename is there. If you want to rename a file, you can do that one. And the uname results is there, which is on uname result is on both of them. So you could do like, for example, let's go np.os.get current working directory. This one is going to print the current working directory, which is where I started my Jupyter notebook. And then if I just do np.os.get login, and then that would give me the login, which is Wahid as the user ID. And this one is similar to running the np.os.path. Let's see if the path is, it tells you where the Python path is. Similarly, on the Linux side, np.os.path. would just give you the path there. So, and you can see that the Python path, the IPython or Python, whatever interpreter that you're using, you can get that one. So this Wahid for the environment, I could have just also done this and 2 commands, bang, and say environment, echo, we could, and since we're on Windows, we're going to use set and then say find a string /I and then look for the default where Wahid is used, and then run that one, and then run this cell. And notice that here, all the environment variable that has Wahid, the home path and everything, one of them might be saying the username. So username. So if I just search for only, instead of Wahid, I search for username, and that the /I user itself is good enough. I don't have to say username because that the string is going to match everything with user. But if I want to make it like username here, username, and then because I have /I, it's going to just match out any string that has uppercase, lowercase, I meaning ignore the case, and it's going to find that. And similarly, if I just look for the path command, path, and then since path is one environment variable, it shows me the entire path here. Similarly, if I say home or the home directories there, and you can see if there's a home drive, C drive is showing there. On the Linux side, the same thing. You could say np.os.get environment, and then here the environment, you could just type in home. That would give me the home environment. If I want to get the print working directory, pwd environment variable, and here I could run the entire command with the system, and then run the env command instead of set, and then get the output of all of them. And if I'm looking for something there, and this time instead of find string, I say grep -I, and then let's say, for example, I'm interested on home Wahid, I could just look for home. That would just show the home /Wahid is the information there. Similarly, if I say, give me the user ID, UID, and then it's going to show me that. The 256. So the command, like group ID with whatever those information are there, you can also do the system and type in the ID command here, and then that would give you the user ID, group ID, all of that detail there. Okay. So I'm going to exit out of this, and then basically, I think we're done with this video. It is a really long video, but I showed you a lot of stuff on the both operating system. To recap, you're learning Python NumPy module, but when you learn the NumPy module, the OS, I covered a lot of operating system, Linux and Windows, and a lot of the examples and with a lot of documentation. So please make sure you go to the YouTube channel, join the channel, and then you're going to get a lot of documentation, a lot of videos online for you already, a lot of YouTube stuff, a lot of command lines that you can practice as well. And thanks for watching. God bless you all. Take care.